my camera turned on. There we go. So you can see I have 5 rocks sitting on my desk. The first rock is fluorite. The second rock is granite. The third rock is calcite. The fourth rock is sandstone. And this last rock here is lodestone. And you can tell that they don't all look the same. They have some properties, and I'm going to record some properties and use some tools. So the first tool I'm going to show you is actually my science notebook. So you can see I titled this table here properties of rocks, and I've named my rocks fluorite, granite, calcite, sandstone, and lodestone. And we're going to look at the color of them and some other details of them too, which brings me to my second tool, which is a hand lens. So I've got that in a little holder right here. So there it is, my hand lens, and I'm going to stick this in front of the iPad here so that you can see it. And let's take a close look at our first rock, fluorite. There it is. It's kind of a greenish color. It has some crystal structure to it, a little bit shiny, some white in it as well, and some black. And sometimes, no, that's not going to want to work today. So there's fluorite. It's kind of an interesting, pretty rock. Next, we have granite. And this is called pink granite. And you can see that it has a pink color to it. There's also some black. And as I turn this around, it sort of twinkles because it's got tiny little crystals in it. Their crystals are much smaller than the fluorite crystals, but they are crystals nonetheless. So again, that's the pink granite. And then next we have the calcite, which is a white rock, and it has some crystal structure to it as well. Kind of sparkles or shines. Not all of it is pure white, but it's mostly white. It's not the most pretty sample of calcite there is, but it is calcite nonetheless. So there is some calcite. Next is sandstone. You can almost see little grains of sand in this rock because it is made up of sand. That's why it's called sandstone. And last is lodestone. It's black. You might notice some little pieces kind of sticking off of it like that. I'll explain what those are in a little bit, but I don't want to explain just yet. But again, that is lodestone. So there we have used the hand lens to take a careful look at those 5 rocks. So I'm going to set that aside now and get my notebook back out. Let me find the pen I just dropped. Well, I'm going to have to get a new pen. All right. So we're going to write down the color of these rocks. Fluorite has kind of that green color to it. So let me write down green for fluorite. There it is. Fluorite is green. And next we have granite, which is kind of that pink color. See if I can get that to focus in on it better. There we go. So I'm going to write pink for granite. Just like that. And then next we have the calcite, which is that white color. So I'm going to write white for calcite. And then we have sandstone, which is kind of gray to me. So I'm going to write gray. And then last we have the Lodestone, which is black, almost pure black. So let me write black here. So there I've got that first column of my notebook completed. Fluorite is green, granite is pink, calcite is white, sandstone is gray, and lodestone is black. Now it's time to check and see if they are attracted to a magnet or not. Or another way to say that is, are they magnetic? So here's my horseshoe magnet that I'm going to use. You can see that, well, no, it's right on the bottom too. Sometimes the magnets are exposed on the bottom, but they're inside the plastic. And if I touch the magnet to fluorite, it is not magnetic. So let me write that down. That's a no for fluorite. It is not magnetic. How about granite? Is granite magnetic? It does not seem to be attracted to the magnet at all, so no. How about calcite? Again, no, it is not attracted to that magnet. How about sandstone? Again, no, not attracted to the magnet. How about lodestone? Well, that one, yes. The magnet picked it up. So lodestone is magnetic. It is attracted to that magnet. I'll even kind of pull that back off of there and set that back down so I can now record these observations. So granite was a no, calcite was a no, sandstone was a no, lodestone was yes, attracted to that magnet or magnetic. So there is the property of magnetic, and now we're going to do the property of mass using a pan balance. So I'm going to get these rocks out of the way here. Get that magnet put away and take out my pan balance. Oh, and let me get my camera turned back on. There we go. So there you can see the pan balance. Let me move that just a little bit closer. And it is about perfectly balanced because this triangle is pointing at this line. And you can use a pan balance a couple of different ways. One way is to take two rocks and compare them. So if I put the granite on this side and the sandstone on this side, you can see that granite is heavier than sandstone because the granite went down and the sandstone went up. So that means granite is heavier. But I don't want to just compare rocks. I want to measure the actual mass of these rocks. So I'm going to use some mass pieces. So this is a 10-gram piece of mass here. We use grams to measure mass. It's kind of the bigger one. I also have some 5-gram pieces. They're a little bit skinnier. They're only 5 grams. And I have some blue ones that are only 1 gram. You can see they're really skinny. This only weighs 1 gram. So I've got my pink granite there. Let me add 10 grams and see what happens. Nothing happened. It didn't balance yet. So let me try another 10. So 10 plus 10 is 20, 30, 40, 50. Whoop. It went too far down. So I'm going to take 10 back out. So 50 minus 10 is back to 40. Let's try a 5. So 45. I can see it's getting closer. So maybe we'll just try ones now. So we have 45, 46, 47, and there it balanced. So I know the mass of my granite is 47 grams. So I recorded that in my notebook. I think that's all the time I've got for doing these. So I did pre-measure these. So my calcite was 51 grams. The sandstone was 11 grams. The lodestone was 104 grams. The fluorite was 53 grams. So if I were to measure all of those, it would look like this. And I did that ahead of time because I knew I wouldn't have time to get all of this done. So that is using a science notebook to record properties of rocks, using the hand lens to carefully observe rocks, especially for their color, using the magnet to see if they're magnetic or not, and using the pan balance to measure the mass of each rock.